Good afternoon, everybody. Welcome to the STEM seminar. Let my colleague William Monarrez to introduce the presenters.
Oh, thank you. Okay, yeah, thank you everyone for being here. I'm pleased to be here today to introduce our colleagues, Dr. Amy Wagler, Dr. Larry Lesser, and Dr. Angelica Monarrez. I appreciate your flexibility working with us with the schedule change we had last week and the week before, and we are really excited to have you here to be sharing your research on English language learners and statistics education. Very informative of the student population we have here in El Paso. And again, on behalf of my colleagues, Dr. Ruby Lynch Arroyo, Dr. Shano, welcome to STEMers.
Hi everyone, thank you for coming and thank you for inviting me. So again, my name is Angelica Monarrez. So I'm here to present this study, which actually part of it was done as my thesis study, which was done in 2012, I think, a long time ago.
Is it that year? Wow.
Yes, well, let's say 2011, 2012, my part was done in that year. So just to see like some Ph.D. students, I think I just wanted to add I'm going to talk a little bit at the end about the process of this whole sending it to publication and then getting it ready. So first, let's talk about the study. So it's called Range of Meanings and Sequential Mixed Method Study of How English Language Learners Encounter Assessment Items on Descriptive Statistics. So pretty much the idea of this started us wanting to understand how language background affects student learning statistics, because mostly how ELL, English language learners, students understand different statistical concepts, especially in those assessments that already have been validated by other researchers. However, usually in these types of tests, English language proficiency and cultural expectations are likely to affect the validity of these of the items in these types of instruments. Sometimes we just take them as they've been validated, so we should be using them, but sometimes they have been validated with a different type of population, and we don't know how students of the English language learners will respond to these type of studies. To these types of items. So why is it important to talk about ELLs? Because the population of ELLs in U.S. K through 12 public schools is growing very rapidly. As you can see from the numbers, it was first 1 out of 20, then 1 out of 9, and it is expected to be 1 out of 4 by 2028. And for the focus of this project, we focus on Spanish English language learners. Not only because that's the highest population here in El Paso, but also because it is the highest population of English language learners in the U.S. So when I started doing the literature, I wanted to find something about ELLs in mathematics and statistics, and I found out that most of the research has been done only in mathematics and ELLs. And most of our research has been done in K through 12 populations, so either elementary, middle school, high school. Not a lot was in college, and also not a lot was done specifically in statistics. However, statistics classes are growing in not only in K through 12 but also in college. A lot of people are having to take statistics classes. So here, another study by Dr. Lesser and Windsor found that ELL's movement among everyday and academic registers. So there's some confusion between the everyday language that we have between some academic language specific to statistics. So now there's a growing body of literature of ELLs thanks to these two researchers here. They've been doing a lot of different research on ELS and statistics. And then another one that is very interesting is the role of context. Because certain problems in statistics require, they're more like word problems, what we know as word problems in mathematics. And sometimes they have a very different context that ELLs might not be familiar with. So, another also research by the Lesser and Wagler found that ELLs are more likely to experience registered confusion. They find the context of a problem difficult to understand, and they have difficulty understanding statistical vocabulary. So, even when I started studying statistics, even right now, some of the statistical vocabulary that is very specific, I still find it a little bit confusing to me. So for me, for example, one, and it's also here in the study, is the idea of range, because in Spanish could be translated as rango, but rango in Spanish, at least the way I understand it, is a little bit more about like military rank, like rank. So there's just some confusion sometimes. That it might not be necessarily that is, we don't understand the concepts or we can't do the computations, but it's the context that is making it a little bit more confusing.
Can I insert a quick comment?
Yes.
We certainly don't want to imply like a deficit model because there's certainly non-ELL students that also struggle with a lot of these vocabulary issues, and there are many situations in which someone who knows Spanish really can use that as a resource to figure out things more easily than someone who's monolingual English. So just to kind of put that comment out there.
Yes, definitely. I think what we're trying to say is that sometimes these instruments might be done with our population that we don't understand, but we can do changes. Especially at the end, we're going to give you some recommendations, that is how to use the Spanish language or their own resources to help them understand statistical concepts. So this is a sequential exploratory mixed methods model. I'll explain a little bit more what that means in another slide. So the instrument is a collection of items assessing conceptual knowledge of measures and center of variation. This we chose center of variation based on previous literature that had already found that ELLs may have issues with those topics. And it's the ARTIS database, which means Assessment Resource Tools for Improving Statistical Thinking. So this is a huge database that has lots of different items to assess statistical concepts. So what we did is that we chose 6 items that reflect the concepts taught in introductory statistics, plus 4 written by Amy and myself, because we thought that those ones were also going to give us some insight. And then we also use 3 items for classifying participants as ELLs and non-ELLs. Again, we also are aware that being an English language learner, or what we call now an emergent bilingual, it's a continuum, right? However, for the purposes of this study, we try to see it more, with that idea that it's a continuum, that's why we use 3 items and we weighted them. And that's why that's how we were able to classify other students as ELLs and non-ELLs, because we needed to have just a separation. However, understanding that your proficiency in English also depends on domains, right? You could have English proficiency in everyday language, but maybe academic, it's a little bit different. But again, just for the purposes of this study, we needed to separate them like that. So research context, like I said, it's a large urban research university located on the U.S.-Mexico border. We also collected data on a community college, and they both have high population of Hispanics speaking ELLs, and as we know, the community college fits the university. So pretty much it's kind of like the same type of students that we have. So hopefully you can sort of see this. So the sequential exploratory mixed methods model means that we collected the quantitative and the quantitative. We collected the quantitative data and then we analyzed it, and then we collected the qualitative data and then we analyzed it, and then we tried to do some triangulation between the two. So the results that we got from the quantitative data help us understand that there were some differences, and then from there we wanted to see, well, what type of differences or why is happening with those students. And that's why we did the qualitative data collection. So for the quantitative, we collected 347 surveys, which is the same survey that I just gave you. It has all the items. And then for the qualitative data collection, we interview 4 students, and they answer, and during those interviews, they're required to answer the same questions, and then provide their thinking on how they solve that question.
And those 4 are a subset of 347, right?
No, actually, that's kind of like a limitation because we weren't able, they were done in separate years. So by the time we did the qualitative part, these students, we couldn't really find them, or they have already moved to...
They were in the same population, though, so
Mhm.
it's not.
But
That's the part we should mention Lorena's.
Yeah, this, and those interviews were conducted by Lorena Galvan in math as well.
so they're not part of it, but they were taking very similar classes with similar, actually, professors. And we try to make it as like aligned as possible with those 4 students.
A technical question. For the chi-square test for independence, global is the accepted name. Why global?
It could, because it's overall, so it was simultaneously testing all of the test endpoints for differences between the ELL and non-ELL populations, rather than taking each test individually and saying, here's the difference between ELLs and non-ELLs. You can simultaneously test all of them, and it's called a global test.
Oh, that's what global refers to.
Like family-wise, is that kind of the same idea?
Well, it's a way to control for multiplicity. It's just functionally, rather than what I do more normally, which is taking the errors and using probability models to mess with the error. So it's a kind of a before-the-fact error control method. Yeah.
And then for the qualitative data, we went through the interviews. There was an open and focus coding. So this is a little bit about the background of the students that were interviewed. Again, they also did, let me see. Can you see that?
Yeah, I can see.
Yeah, we have another screen here.
Yeah, we got you. I only saw that.
Oh.
I kept wondering why you were looking at the wall over there, and I was like, oh, okay.
Because it's background.
Yeah, very good.
Looking at the table with the food.
So again, based on these 3 items, they were classification either being an ELL and a non-ELL here. However, here, even though it wasn't considered an ELL, still speaks some Spanish, this person. So, and I think this is something that we were talking about once, that it was hard for us to really identify ELLs versus non-ELLs, especially here. Everybody knows a little bit of Spanish, everybody knows English, so it's a little bit more complicated than just saying.
Well, do you want to mention that? So we took those self-reported measures and then used a principal components model to then create kind of a continuum, and it was really interesting, I thought, numerically. Once we got those I remember you plotting those results, and you could really see a division between students. So there were students whose, say, first language was Spanish, like subject 4. that due to high levels of proficiency and relatively low levels of self-rated proficiency and relatively lower levels of percent time speaking Spanish, they were, using the principal components model more alike native English speakers in terms of their proficiency in English. And so,
which I think is also what makes this population of El Paso so interesting, because we have all kinds and we can't just say you're ELL and you're not. When, there's so much change. And these are all, as Amy said, self-reported. So for the quantitative results, not sure if you can tell. So the ball one means that was the right answer. And then it's not that visible, but it's supposed to be in italics, the one that was the most, that students answered the most. So for example, here on item 6, both of them, the one that they did the most was the right answer. However, just here looking at those numbers, you can kind of see, so 48 versus 31, non-ELLs got it right more often than ELLs. And that's kind of like throughout. So this is supposed to be the right answer. Both populations got it wrong the most, right? However, non-ELLs got this one more often. Any questions about this?
Maybe a question on how ELL was self-reported, right? How ELL was defined, particularly with the case of student number 4 in the previous one, because I am
so they were asked 3
Hispanic,
measures.
or just because
No.
I speak certain amount of time.
So it was 3 different things. It was
How come that Spanish person, number 4, identified herself as no ELL?
no.
They
So
didn't.
This is self-reported,
Uh-huh.
and this is after the weighted that we did based on this.
Oh, it's not self-reported.
No. This one, no. These 3 guests, which was, we asked them, what's your first language? We asked them, what's the percentage of time you speak Spanish in a day? And then English proficiency self-rating. This is actually also kind of like an instrument that has been already used in literature, that pretty much goes from 1 out of 10, 1 being not being able to speak, and then 10 being able to speak like a native speaker.
That's the ACT, no,
ACTL?
I don't remember the acronym.
ACTFL.
Yes.
That's the one that on the first page, right?
Yes.
That's how you define it's ELL or not, right?
But then we weighted those 3 with the formula, and then that's how we got.
So we didn't actually say, are you an ELL? Are you an English language learner? We never asked that. It was more trying to get at what proportion of time in their language history.
So then again here, you can see that in some cases, non-ELLs, this is the quantitative part, this is the survey. In some cases, non-ELLs were, when they got it right, they were able to get it right. More students were able to get it right, rather than ELLs.
Because it's hard for me to see the italics. Can you point out which questions have the biggest variation between the ELLs and the non-ELLs?
Just give me 1 second. For example, I would say one of them would be maybe item 10.
And 12?
So, the majority got it wrong, right? But in different cases. So for example, here, ELLs more often chose D, and then non-ELLs more often chose 29.
Not by a lot, though.
Not bad.
Not much difference there.
But the 12, I think, is an interesting item.
Yes. So this is the right answer, which is D. And then the highest one here was, for ELLs, was B. and then for non-ELLs is C. So sometimes when they got it right, when both populations got them right, in some cases non-ELLs were more non-ELLs got it right than ELLs. But also, when they got it wrong, there were also some, I guess, differences between the way and the way that they answered the question. So here, for example, the ones with the asterisk, those were the ones that the notes on the global chi-square of association results and proportion results. The ones that have the asterisk are the ones that denote that there's a statistical difference at the 10% significance level, which means that there was a difference between ELLs and non-ELLs on this item.
And Angelica, why 10% was selected as significant level?
Because
There's a lot of measurement error for these kinds of conceptual studies, and so a very rigid, I actually, the only reason, to tell you the truth, that we chose a significance level is because everybody wants to see one. I'd much rather report the p-values and let people interpret them directly. Right? But I really feel uncomfortable with saying 5% has to be a rigid value, especially in a case like this, due to the amount of error involved in measuring these concepts.
also, I would like to add that when I mentioned the triangulation is that the results from the quantitative as well as the results from the qualitative part allowed us to kind of categorize these items in different areas. So for example, these three will be more context related questions, context heavy questions. We also separate into direct questions, which are those ones that can just be answered by maybe using a formula. And then graphical questions, which are, they could be either context heavy or direct, but they have some sort of graphical or visual thing on the question.
Like the histograms.
Like the histograms,
And by the way, these were all coded, I think, by all three of us, right? And then we it was very clear. The contextual factors versus direct was originally what we had begun with as kind of the framework for thinking about these, because in the math literature, there is evidence that computational problems do not pose difficulty for people who struggle in English language, whereas highly contextualized problems will introduce that. So that was our anticipation, but then this being statistics and not being, just math, the graphical issue also came into play, because there's communication that's different when you start involving statistical graphics.
That particular item number 12, which you had significance on, had non-ELL students, right, or ELL students?
Sorry, what was your question?
The table that you had previously with the items, I think graphical number 10, so non-ELL students performed better than ELL, right?
Yes.
By the number of correct responses.
And then that's something that we found in this study, that since it's sometimes when it's context heavy or because graphical, let's remember it could be either one or the other, that this in statistics it could also be happen that non-ELLs also get them wrong, or they also have difficulty with the vocabulary in statistics. That happens also very often. So then the qualitative results, when they were interviewed, so again they were asked to solve the question and then talk about the thought process. So here, student 1 versus student 2. What's interesting is that the answer from student 1 is more like kind of really explain even further. Like, I don't know what will compensate for the average, and if the other half of the households have only one. I don't know. It makes sense for me without making any math. So it's kind of like getting the answer, but not really being able to understand what average is in its own words. However, when student 2, which is not a non-ELL for him, can't remember, sorry. So when he was asked, how do you come up with that answer? Or what makes you think that will be the answer for this question? Oh, because I divided the total amount by children by 50. And then that's an average of 2.2 children in the town. So this question was context heavy. So when it was a context heavy, the person that was more like an ELO had more difficulty really explaining the reasoning of the answer.
Just a quick question. Is that question one of this year?
It's
Yes.
number 6.
Number 6?
Yeah. I think it's worth reading this aloud because
Yeah, that's true.
to me, this was one of the most interesting questions.
And that's one of the reasons I printed it because
Yeah. Do you want to read it out loud?
do
Do you want me to read it?
yes.
Okay. So the question starts like this. The school committee of a small town wanted to determine the average number of children per household in the town. They divided the total number of children in the town by 50, the total number of households. Which of the following statements must be true if the average children per household are 2.2 children? So then the choices are half the households in the town have more than 2 children, or the second option is there are a total of 110 children in the town. Or the third option, the most common number of children in a household is 2.2. Or D, none of the above. And I don't remember the distribution of choices, but I do recall that there was a lot of register confusion that was conflating common and average when we looked at the responses of the English language learners, because one kind of everyday meaning of average is common. And so when they saw common and average, they were basically conflating those two and tended to choose C more often.
So would it have changed, do you think, if instead of saying most common, you'd said most frequent or something like that? Are there tests where you make subtle changes in the wording and see how it changes the results?
I think, yeah, either that or I personally prefer not using average to describe a arithmetic mean also.
That's the question, yeah.
Yeah.
I was trying to, whether we're not talking about domain specific, but whether arithmetic mean and average is perceived the same, or
Right.
in a different context that might be weighted average, right, or harmonic mean.
Yeah,
So do they
there's a
see that
lot
from
of
the-
different ways we
Yeah,
could talk about
my
it.
question is about,
Yeah.
in Spanish, do average and common somehow interfere, no?
There's a table in Lesser Windsor 2009 that, I don't know if you can pull that up from the internet, that has like a dozen words that related to average in English and in Spanish, and they are all similar. So which makes it very confusing when you introduce all those in the same lesson.
¿Cómo es ese average en español?
You're referring to Maria, what,
¿La media?
Promedio.
Promedio.
that would be what? Oh, yeah.
No, in Spanish,
Be average or common?
But we use
average.
That's more like mean, right?
That's
Yeah,
mean.
that's more like mean, so that would be more the mathematical meaning.
Promedio is the mean.
But when you use the word promedio in Spanish, it's more academic. But if you want to talk in informal informal community, you use common, but it's the same meaning.
How would you say something
For
like,
example, if
oh,
I-
they're an average student? And you're not saying they are the mean of students, but more the, like, they're kind of
Estudiante común.
performance-wise an average student.
Común.
Es un estudiante regular.
Regular. Regular, that makes sense.
Regular.
That makes sense.
Común no.
No, es promedio.
Común, it's more colloquial, like when you're talking to your, like, promedio is more academic, which is
But it's
similar to, but here we have average mean. But I feel like when you say promedio, it's more related to the mean
Yeah.
here. not necessarily average. Does that make sense?
Yeah.
One more question on this issue as well. There are differences even in the use of certain terms in different domains of mathematics, right? So when you were referring to range and a different interpretation of range in Spanish, but even in algebra and calculus, people understand range differently, right? So
Domain and range, yeah.
Does that impose certain confusion as well? Because now we're talking about confusion between the domains of math, not even
Right.
considering the
The same lesson in Windsor paper identified like a half dozen words that mean one thing in math and another thing in statistics. And so that's definitely something to navigate as well as with everyday
That
language.
adds to the confusion, right?
Yes, so that's what we were saying
And that's for
that,
everybody, not just ELLs.
Yeah.
that's what we were saying that this is kind of like for everybody, but also there's differences between the everyday language in English and Spanish, also between academic registers, which means that there's difference between what it means in mathematics, what it means in statistics. In the article, we talk about the skew lines, right?
The skew lines, yeah, like this all came up because I was giving, in one of my stats classes, I had the students do kind of pictures to describe statistical concepts, and I gave them symmetric and non-symmetric distributions, and one of the students came with a illustration showing skew lines from mathematics, because she was focusing in on the symmetric asymmetria, which it relates more to the mathematical notion of skew lines and asymptotes and that kind of area of math. And so, for a long time I just looked at it going, I don't understand what's happening here and why she's not showing symmetric and non-symmetric distributions, but showing something else completely unrelated, and then the connection in language was apparent. I don't remember, I think we looked at that a long time,
Yes,
in fact.
yes. And then the next one, as I was saying, this is more a direct item. This is item 9, I believe, which is a very direct one, right? It's the one that's given a list of numbers, and then you have to find the range. So this is an ELL student also. That is just, I forgot about range. I forgot how to calculate range. And like I said, for me, I don't know why I still have issues with that. Because I also feel like, I don't know. And then this is for item 14. This student also a direct answer. A direct item, it was just like, well, I just know the definition of mean, median, and mode for that question. So for that question, it was just, like I said, we said, well, that's more of a direct item because it's just about knowing those definitions. And then the last one, item 12, this is student 1. And this is a graphical item. So the interviewer is saying, well, could you read question number 12? Okay, I think the letter B. Well, why? I was going to say because the other ones did not really make sense to. So again, also I guess I would argue that this is a multiple choice test, so it's kind of like just putting the other ones away, not necessarily knowing the right answer. Or what exactly does the right answer means.
So I think those two are really interesting because the first person got the mean, median, mode one right because he or she was relying upon just that familiarity with the language used in her statistics class. But then because of the use and frequent use of words like the mean, median, mode, standard deviation, it caused a mistake on the next item. That kind of over-reliance upon very familiar terms and very frequently used terms, because the actual answer, I think on number 12 is to use interquartile range, which is a really important concept, but not something we use, not a phrase we use often, not often like standard deviation or mean or median or mode.
Now that you mentioned interquartile range before, I forget, because I feel like here in the U.S. you use more like abbreviations than in the States. So here is like asking IQR, and for some students is, okay, what does that mean? At least from when I went to school in Mexico, I think in Mexico we don't use that many abbreviations for those things. I don't know. So here just looking at again at all of them together, based on the interviews. So for example, student 1, we found that it was a deficiency in cognitive academic language proficiency, so that's more the academic statistical language, statistical concept confusion or misconception due to context, or problem understanding context. But you can also see that even when we have somebody that is not in ELL, there's sometimes some of these overlap. So for example here, deficiency in cognitive academic language proficiency, it's also here.
I think it's in every single one of them.
Mm-hmm. So once looking deeper into the interviews, we found these different, and this is the one that we were talking about, which is transfer between academic registers, which is not being able to understand the differences between what it means in mathematics, what it means in statistics. So for the discussion, generally non-ELLs perform better in the context-heavy category, but there were a few differences in direct items, as Amy said. Even when you're working in math problems, if it's more direct, there's not that much difference because the language doesn't really play an important role in those questions. But there was also difficulty with statistical vocabulary. So again, confusion with words such as average, range, and variability. Also, mean, median, mode. Some other limitations that we have from this study is that in the interviews, in the interviews, we didn't ask about prior schooling or cultural expectations and socioeconomic status that may also influence language proficiency. So I felt like maybe doing another study where we really go deeper into their schooling practices or practices at home, and then looking at statistical, their understanding of statistical concepts in like a much deeper interview will probably help us understand more these results. And then again, we also know that every test is a language proficiency test, and that it's also hard to measure the language proficiency of each one of these students. I feel like that's why maybe doing like a deeper interview, we will be able to know more about them and their language, because like I said, it could be, my Spanish is really good at home, but I use mostly like right now I feel like my Spanish is really good everyday language, but academic, my English is better right now, me.
When K-12 schools assess someone in all 4 domains, of the ALPS, it takes like all day, right? I mean, it's not just a 3-question test. I mean, they really takes hours.
But we also have some recommendations. Again, we are not trying to look like a deficit perspective. It's more like, okay, this is happening. And the point is that sometimes like I said at the beginning, sometimes we look at these really good instruments and we want to use them here because they're being validated. However, if they haven't been validated with this sort of populations, we might be getting some strange results, right? And if we just go towards those multiple choice tests, we might not be getting the full picture of what is happening with those students. And this could be good for K through 12 or college students, and also ELLs and non-ELLs. So, for example, there is evidence of ELLs confusing academic terms such as mean and median, and everyday and academic uses of statistics terms. So a recommendation could be, okay, highlight vocabulary, assess participants using minute papers describing differences between similar sounding academic words or words with both everyday and academic register. So something, for example, like Larry just said, those tables that they have in their article, where you can see differences between English and Spanish words, but also academic and mathematics. Statistics and mathematics words. That might help. So role of context was more confusing to ELLs than non-ELLs. Emphasize role of data context when testing. Regularly remind students of the data context, and as well as really just asking them, what does this mean to you in Spanish, or kind of try to explain to me what this means in English, in your own words, and just to see whether they are really understanding that. I remember many years ago, I was working for Dr. Lesser, and he came to my office and he told me, can you do a tally of the students that you're grading? And I just looked at him like, what's a tally? What does that mean? And I went, and I'm like, what is a tally? But I think, if I remember, you just looked at me like, do you know what's a tally? And I'm like, no. It's like, oh, those things that you do where you put the little
Boring, yeah.
things. I don't even know how they're called in Spanish, but I've been using them all my life.
What are they called?
I don't know, do you know what's a tally?
Tally mark.
Counting mark.
Cuando le pones
Yeah.
1, 2, 3, 4, 5.
Un conteo.
Conteo?
Conte.
I guess.
Well,
I didn't know.
yeah, that's interesting, and well, I'll wait until
Okay.
questions.
So conclusion, statistical ideas are communicated using language and conceptual knowledge. Depends heavily on the use of language. One thing that I want to say is that sometimes we see mathematics as being this thing that is just numbers, and statistics as well, right? I feel like if we need to look at the language in mathematics and in statistics, we need to look at it even further, because there's so much language, and especially when you get your results, whether it's descriptive or inference statistics, the language is so important, and you need to be able to understand how to put it. I know I have some friends taking statistics right now.
They can relate.
Yes, because it depends on the way that you write it. It might give you another idea, or the way that you understand the problem. You might be doing it different. So, and again, if assessment items favor one particular population over another, then it is not possible to make fair comparisons across populations. And here we will be looking at equity issues that we are making those comparisons, not knowing that in reality it doesn't function the same way for both populations. Then definitely the population that is favor would always do better. And again, further research is needed to understand how all participants move from the everyday language to the academic language of a technical word used in statistics. So this is my information, our information, and this was based on our paper that was published just last year, towards the end, I think.
Actually, it was published just like a month ago.
Oh, that's true, but they said
It's the November 2018 issue that got published in March.
Yes, for some reason they were running late.
Yeah.
So for my
Online first then? They do online first, right?
No, it just, they wait till it's all typeset and then they publish it. And it's a journal that you can just get to on the internet. You don't have to go through the UTEP library portal. It's open access.
It's open, yeah.
and for my PhD fellow students, this was like I said, my master's thesis. It felt like it took forever, mostly like in 2013 we tried to get it done, just my quantitative part, it didn't work, and then the qualitative part was done, and we sent it. I think I need to thank Dr. Lesser and Dr. Wagler because they did not forget about it, and suddenly they were like, we need to send this, and then we sent it, and then they gave us, I feel like a year, a couple of months
Took a long
to
time.
do revisions.
They gave us a year, and we took almost all
And
of
we
it.
took almost all of it because we had all had.
They gave us a year, we took the last month, which is what usually happens.
Yeah.
We send those ones, they send it back to us, and it was good. And then after that, it was just waiting for them to publish it. But that just pretty much depends on the journal. Any questions?
I do have a question.
Mhm.
So these questions, where all the participants have done them in the same order, in the same sequence?
Yes.
Because I wonder if there has been any, like, from a linguistic background, cognitive overload is always something that we have to think of as we do
Yeah.
this.
Yeah.
So if you've done these in two sets where the questions are asked in different...
We also tried to do them around the time where it was kind of fresh for them during their classes.
Right.
Those topics were kind of fresh, right?
Yeah.
So we did it around those like, I don't know, I think it was like in the middle of the semester.
Yeah.
Uh-huh.
You make a really good point, though, because uniformly from the interviews, another thing that wasn't really like a research result, but people told us is number 6 was just the hardest item for almost anybody. Because it is really testing, can you reason statistically about a very real-world situation, but draw statistical conclusions that are highly conceptual about a real-life circumstance. That's an average of 2.2 children. What does that really mean when we say an average of 2.2 children? And some students really kind of felt like, oh, this is so difficult, and it was a little off-putting to them for the rest of the set of items. We sequenced them according to the topic and like when they would have encountered it, but it actually was, arguably the most difficult, challenging question.
I wonder if your results would have been different if they
Yeah.
were, if you've divided your participants into two groups where the sequence of these questions were the exact opposite, and so that you control for that cognitive overload.
Yeah, and I think that would be a good, interesting future study because
I think in
issues with that.
statistics, you like she said, we try to put as less error as you can.
Right.
But again, that's why on the limitations, there's always these issues of like cognitive load, or also the way that people answer surveys might not be as reliable as possible. So you try to make it as errorless as possible in statistical analysis. Same with the qualitative analysis, trying to understand what the participant is telling you, and again, not necessarily, we're not trying to generalize what happened in the qualitative part, just trying to kind of take light of what we found on the quantitative part and try to put this for examples.
Yeah, and another
that we
point
have.
too is this items 6 through 12 are from that artist database, and so they appear in the order in which the material, again, is encountered typically. So it's probably the order most people would place them, just due to that, without thinking about it. However,
Content?
yeah. However, I mean, I think it's a great point, and it's, exactly why we don't lead a exam with like the hardest question on the exam,
Right.
So I think it's an interesting thing for, not something we could really focus on this one, but interesting question.
Yeah, the high-stakes testing of our K-12 students, they talk about the inverted smile, where they start off with the easy questions so they don't get discouraged, do the hardest questions in the middle before they start getting tired, and then go back to easier questions as they get tired towards the end. So it's...
And that kind of, I think most of us try to do that on our exams, although I'm wrong a lot of the time about what I think is going to be hard.
There's all these personal variations.
I know, I always like, really, that one was hard?
And I think that's why the recommendations are important, because it's more of like talking to them when they're in the classroom, rather than just looking at these results from these tests. That is just like, okay, it's wrong. But when you talk to them and then you give them more possibilities or more, let's say, vocabulary, then you help them. Or when you kind of talk to them, then you see how much they can bring, like other resources than tell you, oh, it's this, and yeah, and in Spanish it means this, and I've been doing this for so long.
You know what I think would be also very interesting, now that you were guys trying to translate range, right? Back and forth. What would be really interesting if you regroup these questions and then that focus word that you're trying them to, that's the focus of the entire question, like calculate the range or do that. If you group them by cognates but false cognates, because range obviously is a false cognate. It sounds the same, but it means totally two different things. So if you do true cognates and false cognates, and you regroup those and see how, like what negative and positive transfers might appear.
Yeah.
Neat idea.
It's a good idea.
That's a good idea.
Everybody's taking notes.
I'm looking
But
at
I think it's complex too, because we also talk about rank order statistics and all kinds of things, so there's so much, so many transfer issues there.
Right.
And
I just speak because I'm in linguistics.
Yeah.
I have, if you tell me to calculate the range, I'll probably just pick up my calculator. But, range.
Right. Where's the range function?
So, but from a linguistic background, I'd say it would be really interesting to see how these linguistic transfers affect their processing. And also, if you time their processing time, that would be really neat to see what processing time, do true cognates facilitate faster processing time? So that would be really
to make
neat.
those concepts more ready.
And I feel like in statistics
Yeah.
courses you have that opportunity more because the language is so rich. Like you will have the opportunity to get those things. Like it's so
Absolutely.
interesting.
Yeah. Sure.
Since we're talking on item number 6, quick question. I'm putting an ELL hat on my head. So the way I would read the question being ELL, which of the following statements must be true if the average children? I would feel really confused because I need number of.
Average number of, right.
So is that purposely done or is that what?
These were just written by statistics education experts, and I don't think they were paying attention to use of language in particular, because these items were all really developed with an English-only population in mind.
Like
So in
But I agree that inserting number of would make it more
English
clear
it's
for
common
everybody.
to say average children?
The number.
If the average children.
Well, sort of like if the average
Yeah.
children per household, like as a variable, but that, I agree that adding number of would have made it more clear.
Yeah, I just don't think, so this is partly why we did it, because we saw there is a lot of work that Larry's more familiar with than me within the stat ed world on developing really good quality assessment items, and they are fabulous assessment items, but very few people are thinking about, all of these happen to be done in places like Minnesota and a few other places kind of more in the Midwest, and they're not developing them with English language learners in mind. And so it's how will these really work on populations that don't speak English as their first language? Are there going to be differences in interpretation? And so that really inspired.
as well as having conversations maybe with linguists or when creating this type of test.
Yeah.
They don't really do that.
No, they really don't.
But they should.
They should.
Yeah.
They should.
There are so many neat things that you can do, like control for frequency or word length, or there are so many neat things that you can do when it comes to questions like
Use
that.
some of that computational stuff. Of course
I mean,
we would
in other
like that.
papers, Amy and I have written about, like, the lexical and grammatical indices of, whether words are K1 and K2, and academic words, and the cohesion of the text, and how you can rewrite your curriculum materials to make them more reader-friendly for everybody. But, that's...
Yeah, we use some more like lexical analysis tools to look at frequency of those K1,
Cometrics.
K2, and then measures of cohesion, diversity, and other kinds of measures of complexity, both grammatical and lexical in nature. And we found, what's interesting is we found differences in how the writing occurs according to the subject area within statistics. So as you
More than between books.
Yeah, more than between books. Across books, it seemed to be pretty uniform use of language. But when you're talking about introducing measures of location and variation, versus
Line of fit.
regression
Yeah.
analysis. You use really different ways of describing those topics, and it's very interesting, all within the same book.
Oh, in the same book.
Yeah.
Oh, okay. What about,
Are they starting gentle and then piling on the
Yeah.
terminology?
Well, it may not mean so much that, it's just that some topics are just inherently harder to
Harder to
simply.
describe.
Right.
Yeah.
And by the way, just a comment for everybody, if you're interested sort of in what's now like a decade's body of work of our colleagues on this stuff at UTEP, if you just Google Larry Lesser ELL, there's a simple web page I made that has links to all the papers, basically, including the 2009 paper we mentioned. Yeah, you already know about it. So you can find plenty of this stuff later if you'd like.
Yeah.
I have a question, a comment and a question. The comment is that, for instance, the third item there, good working knowledge of formulas without knowing how to properly apply them, I think that applies to lots of people, that
Yeah.
independent of language.
Sure.
And I think Larry's mentioned this before, that lots of things that you can do to help ELLs actually helps lots of other people.
Everybody.
Absolutely.
Yeah, sure.
Absolutely.
especially now that in college, most majors are taking statistics, and they don't, might not have taken a statistics class in a very long time.
Oh, yeah.
Uh-huh.
Or
So for
ever.
them, it's very new. Mhm.
Yeah. And then my question is, how does this, you mentioned comparing statistics with mathematics. I'm wondering about comparing statistics with all sorts of other academic disciplines or areas. And so, mechanical engineering, but that would definitely be at the college level, not the K-12 area. But is there anything done on, are certain areas easier or harder because they have more cognates or less cognates or other stuff that I don't understand? And are some areas better than others for this sort of thing?
So at that time, I wasn't thinking about that. I thought about it when I took statistics classes in the Ph.D. program, because it was very different than taking statistics classes in the mathematics department. It is different. It will be interesting to look more into that, but I don't know. Just to me, it was, the level was different. The language was also different than taking it in a more like theoretical applied science.
So now you're comparing statistics in
For social
math?
sciences
Okay.
than statistics for statisticians.
Okay.
But you're talking like statistics versus physics versus
Yes.
biology.
Oh, okay.
Yes.
Yeah.
I don't know.
There are books out there and a lot of articles on ELLs in science. So, I mean, it has been looked at.
Okay, I was just curious.
But I'm sure there's a lot of individual variations within.
There was one of my favorite, because I barely read the literature like in other subject areas, but there was one remember that paper written by a biologist, and she took, because biology was always a little off-putting to me because of just all the big words that you had no concept about what they meant, and you were like, I'm just supposed to memorize this word for what reason? And, and then so she wrote her whole curriculum, instead of using the technical words that can be very difficult for students learning biology, she just described concepts. So she'd say water-loving organisms, instead of whatever hydrosis, whatever.
Hydrophilic.
Hydrophilic. That was
Just
it.
from what I remember, I came
And
here
things like that. And it increased her students' understanding and comprehension of the big concepts dramatically by just getting rid of the technical words at the first time, describing the concepts, and then saying, oh, by the way, water-loving organisms, we call them this, and here's why, instead of approaching it like, here's a name that we're calling something.
Just from my experience, what I remember, I came here just for undergrad, not really a lot of formal teaching in English, or any English classes I never took. I would say, politics history was kind of hard, but I think the hardest one for me was geology,
Oh.
the language in geology. So I don't know,
Well, I found
I still don't understand anything they were saying.
Yeah.
You know what a stratified sample is?
In statistics or geology?
You're bringing the memories.
Yeah.
I don't know, but geology
My
was,
sediments
I remember I did have to have that book and then something else to be able to translate what it was on the book.
Yeah, yeah.
Because it was just too much. Because politics and history, it was hard, it was,
Too many?
yes, to understand in Spanish, there was no, I guess that no many resources that I could draw from in geology, but there were more resources that I could draw on in history or politics or other classes.
Yeah.
Angelica, do you have information about nationality or at least where these students, ELLs, completed their K-12 education?
No, it was,
In UTEP?
no, so we just have age, year. Those were the only demographic information. That's why at the end I said it will be more interesting to see where they're coming from, their schooling, how much, the projects that I've been working on in engineering, that's something that we found very interesting, that when you talk to them more closely in an interview, they tell us more or less their path, how they came here, when they came here, their experiences with English, with Spanish, then that helps us understand more their experiences now in college. So that's why I was saying that as maybe future research, we will have to look more closely into that.
Yeah, that's an interesting factor because
Yes.
I would say when we work with or study with Latino population, one of the main, if not the most distinguishing factor in Latin America is how heterogeneous is this region in many ways, geographically, culturally. Yes. One is education, and when we were discussing how do you say this in Spanish, I went to my home country, I went to Bolivia, I think of Panama, because what something means for me in my home community, it means a totally different thing in another region of my country. I'm not supposed to say certain things in another region because of different, totally different connotation that means a different thing. And education is one of those things that differs also. For instance, if we have students coming from Latin American country where statistics is a mandatory subject in high school, but probably this ELL comes from this country where statistics is not. And there are more cases like that may determine at some level how they respond and perform in this type of learning environment. So that's one, and the other one is literacy, like Sarah mentioned before, like if they have high levels of language literacy in their native language, that transfer to the mastery of a second language and a third language, which is math or statistics or science. So that's another.
Yes, and from my experience with other parents, what I've seen is like that difference, because some students said, I moved here when I was in 5th grade, or I moved here when I was just like me, like just for college. And they have this all very different experiences also. If they were in Juarez, but they went to private school, it's very different than going to public school and here. So I think it's just talking to them more closely, and then that gives you really the whole picture of how they understand later these concepts. Sometimes we don't think about asking them that because that has nothing to do with statistics, right? Which maybe at that time we were not thinking about it, but now that I look at it, and it's like, yeah, we need to look at everything, like we said, the cultural. I forgot which slide it is. We need to look at their cultural practices, not just at school, at home, but also their socioeconomic status is very different. Also, just in Mexico, like you're saying, is the same. I'm from the north, she's from the south. For me, that's the south, but for her, that's the center. Anything below Juarez is south for me. But it's very different, the way that we talk, and then the way that some academic things were taught in different places.
I was going to say, so I think, I may be just repeating what you've said, that, I notice there seems to be a difference between students who went to high school in Mexico versus went to school in the U.S., regardless of language, just because of the different emphasis on how math is taught and so
Ways
forth
it's
like
practiced.
that. Yeah, and how do you then pull out that factor from just the pure, the language? Like, would you get something different if you just looked at students who went to school in the U.S., ELLs versus the not ELLs, and then separately in Mexico? And as you're pointing out, the difference between the private schools and public schools, and I don't know, different.
We're just into a rabbit hole, like, we could do that.
Yeah, I
The
know.
class survey asks where they,
That's right.
every grade.
That's right. Another survey that we've used in the past does have them mark which years they went to school in Mexico with English only and or Spanish only instruction versus the United States, and also asks if they went to the United States with Spanish instruction or English only instruction. I think your story is such a clear example of the influence of that schooling environment, because you came to study at UTEP with a high level of mathematical maturity already.
Yeah.
You already had achieved high levels in mathematics before you came, and then making that adjustment to studying mathematics as an undergrad and then graduate student in the States. I think you have an interesting perspective, because a lot of the students who transfer in do so maybe earlier in the year, and so they have that time to adapt, yeah.
And this is the study that I always wanted to do, which is how they learn math in Mexico and how differences and how they learn math in here. Like for me, just solving for X is just solving for X. I just change it. And then here you do have to do all those
Steps.
5 steps. When I came here, I was like, why do I have to spend that much time? It just goes to the other side, and then X is equal to 5, something like that.
Well, even something as simple as long division, often, people
Oh, yeah.
keep these subtrahends mentally and not write them down.
Your long division is like this
so-
long.
Yeah.
And in Mexico it's this.
Long division,
It's
yeah.
Yeah, I have 2 questions. Out of initial 347, and based on the response on item 6 to 15, was there any significant difference between overall performance of non-ALL to ALL students?
Do we do the overall?
I'm sorry, I'm not understanding.
You mean like grading the whole
Just
thing?
take the content questions 6 to 15
6 to 15.
and look at the overall performance of...
That was the global test that you asked about. So when you're doing this kind of a statistical analysis, you look at the full set of items first, and then see, is there an overall difference prior to going to the specific item-by-item
What was
differences?
the difference?
And so that there was a global difference between the set of items.
In favor of
Yeah.
non-ALL, I assume.
Yes, in favor of non-ALL. I think all we wrote up there was the p-value, but yeah, it was in favor of
And the
non.
second one is more technical. Maybe I missed that point. The questions from 6 to, you said 10 or 12 was
12.
from one survey, and the rest
From the
other?
artist, yeah.
How did
And then
you
the rest
establish
were,
the reliability and validity, yeah.
The rest, we just had long conversations together, and then we came up with some that were significant for us that we wanted to look at.
also informed by the class scale, the Communication, Language, and Statistics Survey. So those pointed out some confusion with certain words, and so we wanted to see, what was of interest is, would they be able to, if asked directly, pick out the meaning of range, average, not because we like to use the term average, but it does show up frequently, in assessment items, and then spread. And I think both average and spread should just never be used in any kind of statistics texts. And I hate that it shows up frequently, but the fact is it does and continues to be. But there is a lot of just confusion created by using these terms for ELLs and non-ELLs.
But
Then I got a problem in what is defined as.
Yeah.
I'm sorry?
the average is the phrasing is defined as is problematic because
Yeah.
defined is like very specific from a mathematical point of view. But maybe
True,
average
true.
is best described as.
Described as, that would have probably been better.
Because you're not going for a very technical, but what
No.
they associate
Yeah.
that word with.
Is associated with, and I think really, I mean, it would have been interesting to make these pick any K out of N type questions too.
Spread is, butter jam dip, that is a spread.
Yeah.
Or extend, open.
Well, and I think our assumption here is within a statistics assessment, of course you can spread your jam, but that's not what we're talking about in statistics class,
Well, one more idea that you might consider is to include, after they do this, you might have another sheet, and each item, you go back and refer on a scale of 1 to 5, how confident are you that your answer is correct? So that one is just wonder whether there's a difference between ELL and non-ELL on their
On
confidence
confidence.
of that answer,
Yeah.
which may be right or wrong, they may be confident of a right or wrong.
Well, and you could see that in the interview results that often they would say, oh, I just picked that because I'd seen that word before, or, there was a lot of uncertainty with their,
In that case, you might add, then probably briefly describe why.
Yeah.
Then you give you some idea.
that would be a good next step for.
Yeah.
Are you still working on calibration?
I have not in a very, very long time. The results were, so for a while I was working on that, the results were very mixed and it was difficult to get overall conclusions with what I had. Because I only did that one data collection in Stat 2480 and I felt like I needed to get more data, but I never did. But I think there's a lot there, the confidence ratings and that sense of calibration. So I did spend a semester where I had students give ratings about confidence on items as they took them in class. And it was very inconsistent. I expected to see high levels of confidence with directly worded items and lower levels of context with contextually heavy items. But it was very mixed according more to other factors, to tell you the truth. It's really complicated.
So then probably that you don't really describe why.
Yeah.
Usually when you come to quantitative, then you probably will test hypothesis.
Okay. Now, I actually have kind of statement connecting to Julian Vieira's results of dissertation, and honestly, I had that interesting feeling that students were using Alex in their pre-calculus class, not only to learn mathematics, but learn English.
Yes.
For mathematics. And so basically, it really shows that there is need for class like English for mathematics, English for statistics, English for physics. And I took such class in my Soviet Union, like for several years. It was English for mathematics, and that's why I speak English right now.
Well, you speak well.
Thank you. But like I didn't take class English for physics. So I had to learn here like what capacitor means, what like specific terms. So it never comes naturally when you study English.
No.
So, and like Alex, you said that maybe creating some apps. Right now we're in this digital era and it's not impossible to give these tools to our students.
Not at all, yeah. Well, and Larry always points out, I know to your students, like the use of that international statistical lexicon and things, making that some sort of interactive resource in a class would be very useful, because I think we'd have to say, we're teaching statistics and the language associated with statistics.
All right, we want to maybe finish and let's thank. We also have little gifts for them and.
So cute.
But it's always good to present at September, so anytime we invite people, please come because we have this little.
Oh, you guys are nice. We're not so nice in the math department.
Thank you.
Thank you. Thank you. Thank you.
Thank you.
I had a team of I'm Amy.
Amy, nice to meet
okay.
you. I'm in the TLC doctoral program, but I'm in the literacy and
Literacy, oh neat. You brought up so many good ideas and interesting points. I think a lot to learn between the subjects because those of us with our math and stat background